This lesson is all about simplifying expressions using a variety of different algebraic techniques. So I'm going to begin with looking at how we simplify by collecting what I'm going to refer to as like terms. Now, a like term is a single term which is connected to another term by a common letter. So for example, x and 2x are both like terms because they're both connected because they're both multiples of x, and x plus 2x would be 3x. And another example could be x squared add 5x squared. So that would be 6x squared because one lot of x squared plus 5 lots of x squared is 6 lots of x squared. So going through our examples then, we've got b plus b plus b plus b, which is 4 lots of b, which we're going to write as 4b. So when we write an algebraic term simplified, the number at the front tells you how many lots of that term you've got, and we always put the number at the beginning of a term. So we don't write b4, we always write 4b. For the second one, we've got 3a add 5a is 8a, but then if we take off 2a, that leaves us with 6a, or 6 lots of a. And again, we don't need to write the time sign, we just write 6a. The next one I've put in just as kind of an example of when we can't simplify. So although these terms look similar, you can see that this is a squared term because it's 3 lots of x squared, and this is just an x term. And so even though they look similar and they've got an x in them, one is a squared term and one is just an x term. So there isn't really a way of simplifying them. So I'm going to write no possible simplification. Okay, the next part of our simplifying expressions is the idea of expanding brackets. And when you see a term on the outside, like a 2 for example in this first one, that means everything inside the brackets is multiplied by 2. Oops. So what we're going to do is we're going to multiply the 3a by 2, and we're also going to multiply the 5b by 2. And so that will give us 2 terms. It'll give us 6a, because 2 lots of 3a makes 6a, and it will give us 10b. So that is our expanded expression. And then if we look, there's no way of simplifying this anymore because this is a multiple of a and this is a multiple of b. They're not connected in any simple way. There's nothing like about them. The next one then, you'll notice on the outside of this expression, we have an x. So that means we're going to multiply everything by x. And if you multiply x by 3x, then what we have to do this time is we have to change the power because we're multiplying. So x times x gives us x squared. So here we've got 3 lots of x squared, and x times the 7 gives us 7x. And that's our simplified expression because, as before, we can't add x squared and x's together. So we've expanded the brackets and we can't simplify anymore. For this final example, I'm going to look at what we can do when we expand and we simplify. So we're going to expand the brackets first of all, which means in the first bracket, I'm going to multiply each term by 2, which gives me 2a plus 6b, because 2 lots of a gives me 2a and 2 lots of 3b gives me 6b. And if I multiply 4 by each of the terms inside the brackets, so 4 lots of b gives me 4b, and here we've got to be careful, we're timesing a positive by a negative, so 4 times minus a is minus 4a, because a positive times a negative is negative. So we've expanded our brackets, and now what we're going to do is simplify, which means gather all the like terms. So let's have a look at the a terms. We've got 2a take away 4a. 2 take away 4 is minus 2. So that means 2a take away 4a is minus 2a. And if we look at the b terms, we've got 6b add 4b is 10b. So plus 10b. And again, we can't simplify this any further because these are 2 different terms. We could write it in the different order. We could say that that's 10b minus 2a, and that sometimes looks a little bit neater to start an expression with a positive term rather than a negative, but both of these are perfectly good answers. Okay.